Hello Year 4, welcome to your science lesson for today. We're going to be learning all about the force of air resistance. Our TLP for today is Can I identify the effects of air resistance that act between moving surfaces? So what is air resistance? What do you think air resistance means? The resistance of air. Well, here we have our little character. Can you see them? I think they're skydiving. And can you see the force of gravity that is pulling them down to the ground? And underneath them, there are arrows that seem to be pushing up. Those arrows say air resistance. That means that the force that the air creates as this person falls, creates resistance to the gravity that is pulling them down. So when something falls, air resistance acts in the opposite direction to the force of gravity and the opposite direction of the object's motion. So if you imagine a plane flying through the air, its engines are pushing it forward. But there is air resistance moving in the opposite direction that the plane is going that will be slowing it down. The same will happen with runners, cars, trains, anything that moves. Let's have a look at a definition. Air resistance is a force that is caused by air. The force acts in the opposite direction to an object moving through the air. So how does it actually work? Let's do an experiment together to find out. Okay, so all we need for this experiment is one piece of paper. It can be scrap paper, doesn't have to be anything fancy, but you need to be able to screw it up. So pause the video now and go and get yourself a piece of paper. Now we're going to think about the effect of air resistance when we drop our piece of paper. So hold yours up. Let's drop it. Oh, mine sort of floated down to the ground. What happened to yours? Now, screw up your piece of paper into a little ball. I wonder what the difference will be when we drop it now. Mine fell straight down. What happened to yours? So what do you think is the difference in the air resistance when we drop a piece of paper screwed up into a ball like this, or a piece of paper that's completely flat like this? So what do we think happened when we dropped our two pieces of paper? If this rectangle represents the flat paper and the circle represents the screwed up piece of paper, we can see we've got gravity and movement pushing both down, haven't we? But here you can see the air resistance, and the air resistance on the flat piece of paper is greater because it has a bigger area. The screwed up piece of paper is smaller, has a smaller area, so the air resistance is less, which is why it dropped down so fast. So different things can affect air resistance. So the amount of air resistance an object experiences depends on three things. Depends on the speed the object is moving at. Depends on the size of the object. So that's what affected our piece of paper, isn't it? Because everything else was the same, but the size of the piece of paper before we screwed it up was much bigger than the screwed up piece. And also the shape. So some things are more streamlined, and that could also have affected our piece of paper. If you want to know a bit more about this, check out the BBC Bitesize video linked in the description of this video. So knowing what you know now about air resistance, which of these two parachutes do you think will fall the fastest and why? That's right. The smaller one will fall faster because there will be less air resistance. Well done. Okay, Year 4. Now we're going to talk about an air-resistant experiment that you might like to have a go at home. If you don't want to have a go at this at home, that's absolutely fine. Okay, we have all the information from Year 4 last year doing this experiment, so you don't need to do this at home if you don't want to. So what you will need is a space to run across, a big piece of cardboard or something to use as a parachute, and a timer. And what you've got to do is find a space, so you can see last year's Year 4 here running across the playground, but it could be a room, it could be a garden, it could be a section of pavement, but please speak to an adult and make sure you're safe if you're doing this. You need to time yourself running across this space. Then you need to find a big piece of cardboard or something that could act as a parachute, and you need to run across the same space and time yourself again. Then we're going to look at the difference between the time it took you running across the space and the time it took you to run across with a parachute.
So whether you're planning to do this experiment at home or not, please find out this sheet from your pack and we're going to have a look at the different sections together. If you would like, you can write down each section with me, or you can just listen. But I would really like everybody to have a go at doing a conclusion when we get to that part. So our question is, will running across the playground with a parachute slow me down? That's what we're investigating. So what are we going to measure? So we will be measuring the effect using a parachute has on the time it takes to run across the playground. So what is your prediction? What do you think will happen? Do you think it will be faster to run across the playground with or without the piece of cardboard? With or without the parachute? So my prediction, I predict that it will take longer to run across the playground with a parachute than without. Do you agree with my prediction, Year 4? If you would like a challenge, you could have a go at writing a prediction that is linked to air resistance. So you might write something like this. This is because the parachute will create more air resistance, which will slow me down. Now, do you remember about a fair test? We need to think of all the things we're going to keep the same and the one thing that we will change. So what things will be kept the same and what one thing will we change? So if you thought of any of these, well done. So we will keep the same yourself or the person who's doing the running. The distance that you run needs to be kept the same. And the type of timer you use to time your run with and without your parachute must be the same. So if you're using a phone, it should be the same phone. If you're using a stopwatch, same stopwatch. And the only thing we're going to change is the parachute. So we're either going to use it or we won't use it. Now, if you're going to do this experiment at home, now is the time to pause and have a go and get yourself some results. You could put them into a table a little bit like this one. So this is last year's Year 4 results. Let's have a look at them together. So here in red, you can see the time that it took them to run across the playground without the parachute. It says in seconds, they've measured it in seconds. And the time that it took to run across the parachute and the time that it took to run across the playground with the parachute. So looking at these results, was it faster to run across the playground with or without the parachute? What do we think year 4? That's right. It was much quicker without the parachute. Can you see here, Group A, it took 2 seconds to cross the playground without the parachute and 4 seconds with the parachute. This one has a big difference. Group B was very fast without the parachute, 3 seconds. But with the parachute, it took them 7 seconds, so it was a lot slower. So I'll just put that up there, and now we need to write our conclusion. So, see if you can have a go. So it says, I found out that. What did we find out? That's right. We found out that it was much quicker to run across the playground without the parachute. So on your piece of paper, have a go at writing a conclusion. Could be something like this. I found out that running across the playground with a parachute is slower than running without a parachute. Now, as a challenge, could you have a go at linking this conclusion to air resistance? So you might say something like, this is because the cardboard parachute has a greater area and therefore there is more air resistance and that slows me down. So I've written, this is because the cardboard parachute has a greater area and my body is smaller and more streamlined. Therefore, there was more air resistance acting on the cardboard parachute than on my body alone, and the air resistance slowed me down. So if you do your own results, if you do the experiment for yourself and you come up with your own results, you could have a go at writing your own conclusion, or you could just write a conclusion like mine from last year's Year 4 results. I really look forward to hearing your conclusions on Zoom later.
Well done anyone who's had a go at doing or writing up the experiment. Here's some ideas of how we could further this investigation, if you would like. So you could repeat the experiment 3 or more times to test the validity. So you could run across 3 times and then you could run across with a piece of cardboard 3 times. Maybe you could rope in some other people from your household who could have a go as well, and then you could compare your results. Maybe you could have a go at using different shape or size parachutes and observe the effects that has on your speed running across a space. If you're really enjoying learning about air resistance, there is another investigation that you could do. You don't have to do this, just if you'd like to do a little bit more investigating. So what you could do is test the effect of air resistance on small objects. So you can see in our little picture, there's a little man attached to a parachute. So you could make a mini parachute out of plastic bag or paper and string. In the description of this video, there is a link to another video with someone showing you how to make a parachute. And you could attach a toy or toys to your parachute and see the effects of air resistance. So you could measure how fast an object falls without a parachute, and then you could attach it to your parachute and see the difference in how fast it falls. Or you could make parachutes of different sizes and test them with the same object. Now in the video, the one that I've linked, I'm pretty sure the man uses an egg. If you are planning to do an air resistance investigation using an egg, please check with an adult. Please do it outside. Let's all be sensible about this, Year 4. But I'm sure you all will be superstars. as always. So good luck, and any questions you can always email or ask us on the Zooms.